Chapter 6, Section 3, we're just going to do the first part, separation of variables, not logistic equations. Example 1, if we have to find the general solution of the quantity x squared plus 4, dy dx equals x times y, we want to separate our variables. So we're going to multiply both sides by dx. So we'll have x squared plus 4 times dy equals xy dx. Looks like we want the x's in the right side. That's the way I'm working it. So divide that both sides by x squared plus 4. And while we're at it, multiply or divide both sides by 1 over y so that those cancel. So we'll have dy over y equals x over x squared plus 4 dx. Now we can integrate. The integral of dy over y is natural log of the absolute value of y plus c, but we're going to put that c on the other side. Here we're going to choose u as the denominator. Take the derivative of the denominator and then solve for dx. Substitute that in so those x's cancel. Pull the 1/2 out so we have the integral of 1 over u to u, which is also natural log of the absolute value of u. And then we're going to do plus c. So we have natural log of absolute value of y equals 1/2 natural log absolute value of x squared plus 4 plus c. Now we want to solve for y if possible, so I'm going to exponentiate both sides. This power could go up here. So make each side the exponent of e. So we'll have y and we'll talk about the absolute value signs in a minute. E to the natural log of x squared plus 4 to the 1/2 plus c. So the property of exponent says that if you have two exponents that are added, that's the same as e to the natural log of one of them times e to the other one. E to the first exponent times e to the second exponent there. And e to any power will always be positive, and e to the constant is another constant, so we don't need the absolute value signs on the y anymore, because that right side will always be positive. E and natural log cancel out, so it's just the square root of x squared plus 4. And e to the c is a constant, so my final answer is y equals c times the square root of x squared plus 4. And that is the general solution. It's called general because we don't know what c is. If we had more information, we could find c. Okay, here's one where we have to find the particular solution. So we have xy dx plus e to the negative x squared times y squared minus 1 dy equals 0. We're going to find the general solution and then use the condition that when x is 0, y is 1. So we have to separate our variables first of all. Let's add e to the negative x, or subtract e to the negative x squared. Y squared minus 1 dy, we'll subtract that from both sides, and then start dividing. So let's get the, what this means is negative 1 over e to the x squared, just so that you are familiar with what I'm going to do next. This means this. So I want to divide by y here. I'm going to get the y's on the right side because I've got a lot of y's over here, and I'm going to get the x's on that other side, on the left side. So I'm going to multiply both sides by e to the x squared and divide both sides by y. So then the e to the x squareds cancel and the y's cancel. So I have e to the x squared times x dx equals negative y squared minus 1 over y dy. That right side can simplify to negative y squared plus 1 over y dy, and then I can simplify that by splitting up the fraction or doing the division, negative y plus 1 over y. And over here, we're just going to keep it like this. So now we can integrate. We're going to choose u as x squared. So the derivative of u is 2x. dx is du over 2x. So we'll have the integral of e to the u times x times du over 2x. So those x's cancel. So then I'll have 1/2 integral e to the u du. And on the right side, the integral of negative y is negative y squared over 2, plus the integral of 1 over y is natural log of y. Throw in that constant there. So I have negative y squared over 2 plus natural log of absolute value of y plus a constant. That looks like an e. And over here on the left side we have 1/2 e to the u, because the integral of 1/2 e to the u du is e to the u, and I plugged in the u. So there's our final our answer. And since it would be really hard to solve for y, let's not do that first. But we do want to use our initial condition. So when x is 0, y is 1. So we're going to put 0 in for x. We're going to put 1 in for y. And that will help us find c. E to the 0 is 1, so this equals 1/2. 1 squared, notice the negative is not being squared. It's 1 that's being squared, and then we're putting a negative on that, so it's negative 1/2. Careful of your order of operations. And then natural log of 1 is 0. So then if we add 1/2 to both sides, c equals 1. So then our particular solution is 1/2 e to the x squared equals negative y squared over 2 plus natural log of the absolute value of y plus 1. You could leave it like that because you can't really solve for y in this one, or you could put everything on one side. It depends how the book wants you to do it. Or it depends on how the multiple choice answers might look. The answer in the book is this. Could we get our answer to look like that? Well, what did they do? For sure they multiplied by 2. So if you multiply this whole thing by 2, then these would cancel, and there's our e to the x squared. Then this would cancel, so there's our negative y squared. If we add it to the other side, then it becomes positive. 2 times natural log of y could be rewritten as, if you put a 2 here, you can put that 2 up here, so it's a power of 2. Then you don't need the absolute value signs. And then you can subtract it, so it's minus natural log of y squared, and then equals 2. So 2 times 1, you just leave that there. So we can get our answer to look like this. So just make sure that you leave it in, if it's a free response, you can leave it in any form you want, unless they say solve for y or something like that. Otherwise, if it's multiple choice, just be able to convert yours to the multiple choice answer. So you got to know the log properties and simple things like that. Example 3, find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. So if it has a slope of y over x squared, that's the derivative. So you have to make that connection. And then we want the equation of the curve. So that means we have to solve this differential equation. So we're going to separate our variables, multiply both sides by dx, divide both sides by y. So we have 1 over y dy equals 1 over x squared dx. I'm going to rewrite that x squared as, that 1 over x squared as x to the negative 2. Because I know my next step is to integrate, and I want it in a form for integrating. This is the natural log of the absolute value of y. And this one I add 1 to the exponent and divide by the new exponent. So then I have natural log of the absolute value of y equals negative 1 over x plus c. I want the equation, so I'm solving for y. So I'm going to exponentiate both sides. So e to the natural log of the absolute value of y is just the absolute value of y. Remember our property that if you have a base to a power that is an addition problem or sum, then it's the base to the first term times e, or the base to that second term. And this is just one big constant. Absolute value are not, the absolute value signs are not necessary here because e to any power will always be positive. And we'll put that constant first. So that's our general solution, and we want it to go through the point 1, 3. So I'm going to put 3 in here and 1 in there. C times e to the negative 1. E to the negative 1 means 1 over e to the positive 1. So if I multiply both sides by e, that will cancel that. So c equals 3e. So my final solution, or my particular solution, is 3e times e to the negative 1 over x. Just replaced 3e in here for c. So that's my particular solution. That's the equation of the graph that has a slope of y over x squared and goes through the point 1, 3. There's your homework.